So hopefully this warm-up is nice and easy for us now that we went over the homework, or at least 1 through 4. Okay, so 1, what do we recognize now that this is actually equal to? X times x, which is log of x plus log of x, right? Which is 2 log of x. Great. All right, this one, what is this one? Log u plus log v. Good. What about this one?
Log 7 minus log 11.
Perfect. Okay. Well, yes, this is to the 4th, but the same logic should apply as number 1. What does this actually say?
Log x plus x.
Yeah, x times x times x times x. Well, multiplication on the inside becomes addition on the outside. And we get log x plus log x plus log x plus log x. I wish there was a shorter way. How many log x's is that?
4.
So that's 4 log x. Anybody noticing anything? The exponent is the same as what? So in this, the exponent was 2, and where did that 2 end up? Out front. How about in this one? Exponent was 4, and it ended up out front. Which brings us to our next property, the power property. Okay? So we're going to prove it a couple more times, and then we'll define the property, and then you'll have all 3 properties that you need. Okay, so with that in mind, how could I simplify log 25? How could I, or at least change the expression to a different form?
Log 5.
Log 5 squared, which then becomes 2 log 5. And remember, this 2 up front means multiplication. 2 times log 5, right? Now over here, even easier, I just would say 3 log x, right? Okay, so that's it seems like we've gotten the property kind of in mind, but we always define our properties. This is the power property of logs, okay? And it says if you have log of any base m to the n, meaning there's an exponent being raised inside the log, then that n comes out front and becomes a coefficient, and it multiplies by the log. Now, I know that we like real examples too, so I'll give you a real example. How about log of 4 and then 3 to the x? Well, that's the same as x times log base 4, 3. Okay? And just what we're doing here, just in words, is the exponent inside becomes a coefficient outside, and more specifically, out front. That wording seems to help people, right? So if you have an exponent on the inside, meaning it's part of the answer part of the log, then it goes to the outside, in the front of the log, right? And it becomes a coefficient. Remember, coefficients are things that we multiply by terms, okay? So it just becomes a number we multiply out front, okay? So here we go. Let's do a couple examples, and then we'll kind of try to go back and forth, and then we'll come to topic 2 of the day. There's 2 topics today. Okay? So, log of 16, kind of similar to log of 25 above. What could I rewrite that as? Log of 4 squared. And then that becomes out front, and I get 2 times log of 4. Now, Remember, the instructions are usually expand or condense. I've expanded this. Have I expanded this as much as I possibly can?
No.
Hint, no. Why were we able to do it with 16? Because it was a perfect square. What do we still see in our problem? A perfect square. So let's keep going. So this is 2 times log, not 4, but 2 squared. Okay, a lot of 2's now, right? And where does this 2 go? Out front.
But then it would be
2 times 2 times log of 2, which is
4 log of 2.
Yep, which is 4 times log of 2. Now, I heard you saying something. What were you saying? We could have just started with?
2 to the power of 4.
Exactly. So we could have recognized this right away and gotten log of 2 to the 4th from that 4 out front, and would have gotten 4 log of 2, the same answer, right? Now, it's totally fine if you do it in multiple steps, because look, we got to the same answer, right? 4 log 2, right? Now, if you're not sure where to get started, just get started. And you will see that, oh, I can keep, it's kind of like when you're simplifying, you're like, oh, I can keep simplifying, right? But if you see the biggest one right away, that'll save you some steps. Okay? Okay, well, we're talking about exponents going out front, and then I give you this one, which doesn't even have an exponent. Did I mess up?
No.
No.
It has an exponent.
What is the exponent?
2.
1/2, right? Square rooting is the same as raising to the 1/2, so there is an exponent out front. Now, what is that? What does that become now?
It becomes
1 over 2
1/2.
1/2 log of x. Okay. Any other way I could express that? Anybody?
0.5.
No, because it's out front now. Yeah,
Log x over 2.
exactly. You might see log of x over 2. Now, what do I mean by c? Well, obviously, I'm going to make you go both ways, right? I'm not just going to make you go from here to here. I'm going to make you go backwards, right? So, for instance, you might see a problem that looks like this. Let's add one. Maybe I give you log of x divided by 3, and I say condense. And then you have to do all of this backwards, right? So the first thing I would say is this is the same as what?
It's
1/3 log of x, which is
Log x 1/3.
log of x to the 1/3, which is log of the cube root of x. Do we see that? Right, so if you see something like this on your homework or on a quiz, it's kind of hinting that it's 1/3 out front. And then that goes to the exponent, and then that becomes the root. Okay?
Do all the steps.
Right? What?
Do we have to do all the steps, like 3 of them?
Like anything else, if you try to do it in your head and you get it wrong, I can't give you partial credit for that. So if you show me steps and I see really good stuff, I can give you partial credit. Right?
Good.
Okay? Yeah.
If we forgot to put like log x over 2, do you remove
Like if you left it as this,
Yeah.
that would be okay. I just want you to be prepared to see this and know it turns into that. Yeah. I mean, I'm not as concerned about that as you recognizing both. Okay? All right. Now, let's practice going back and forth. Okay? Now, what do I mean back and forth? We should be able to expand or condense just like with our other properties. Remember, condense is 1 log, or at least as much as we can, get it down to 1 log. And expand just means pull apart, right? Sometimes it'll mean more than 1 log. With the exponent, it could just mean move it out front, right? But it's basically like the opposite of condense, right? 1 log is as simple as possible. The other way is to pull it apart in any way you can, okay? So for instance, this first one, it's condensed, so we want to kind of, what can we pull out of it?
2.
It's got an exponent, so that would go out front, and it just becomes
2 log 3.
2 log base 3x. And that's as much as we can do with that, okay? And then we're about to jump up a level here, because this one is going to have multiple steps. Now, when you see logs being added or subtracted, look at each one first, right? So just look at this log first, and then ask yourself, what can I do? Is there anything I can do with just that log before I start thinking about the other log?
Put 7 on there.
Right. So I would say, do this in a couple steps. I would say log base 2 of x to the 7th plus, and then this one, what could I do with this one?
Log of 2
log
4.
It's a mouthful. Log 2 y to the 4th. And now that I condensed each individual log, I think about if I can bring them together. Now they're the same base, so I can. Addition on the outside means multiplication on the inside. So this becomes 1 log base 2 of x to the 7th, yep, times y to the 4th. Question?
I originally did it as 28 to the log to the base 2 of xy. Would that work?
No, because they're not the same variable, x and y. So yeah, just be careful that that you have like variables. Okay, now this one, my first instincts tell me based on today's lesson, what am I going to do?
X up front. Out front.
Okay, so this gives me x times log base 3 of 27.
But 27 is
3 and 9.
No, it's
Oh, it's 3 third. 3 quadrat. 3 cube.
What can I do with that information?
We can put the 3 outside.
you put the 3 up to the front.
Remember at the very beginning of logs, I said the log is the exponent. The log is the exponent. The log equals the exponent. So log 3, 27. Here's my base. Here's my answer. This equals my exponent. What's the exponent that goes with this? 3. All right? You don't have to do that in your head.
So then it's 1.
No, we're trying to find what is this equal to. And log 3, 27 equals 3. If these two things are equal to each other, we can put them in each other's place, right? So this 3 can go right here, and I get x times 3 instead of x times all this, which is 3x. Question? Well, this is, if we are, that's a good question. I guess I would give more specific instructions. The more important thing is here is if you recognize if you can turn this into 3x, can you do it? All right? I would give you more specific instructions than condense or expand if that was involved. Good question.
I have a question.
Mm-hmm.
So instead of 27, like we put 3. So
It would be log 3, 3.
yeah, so that's 1.
That would be 1, and it would just be x.
Yeah, that's what I was
Yeah.
thinking about.
Yeah, that's okay. But in this case, it's 3, so it's 3x. Make sense? All right, on to our next topic. Now that we have this property, we can finally use logs for the thing we promised. And what did I promise? Well, remember, this. And this might not be the exact problem that we did, but something like this, where you had like 2 to the x equals 10, right? And then remember we did the log category thing, and there was like the not yet category? Well, that yet has come, right? The reason we couldn't go any further than this was what?
Because you can't multiply that by 10.
Like 2 to the nothing we know is 10, right? 2 to the third is 8, to the fourth is 16. Nothing that we know commonly gives us that x by guess and check or by thinking it through. So I said, don't worry, logs will be our solution. Well, here we go. This is how they're the solution to this problem, okay? So here are your steps for solving using logs, okay? Step 1 is isolate, meaning get by itself. the part with x in the exponent, right? So the expression inside your equation. You won't always have to, but if you take a peek down to the bottom problem on this page, we're not there yet, but you'll see there's a part that has an x in the exponent, and then there's all this other stuff. Well, if that's the case, you got to get the part with the x in the exponent by itself. Move everything else away. Okay? Step 2. This is new. You will log both sides of the equation. So you know how you can, when you're solving, you can multiply both sides, you can divide both sides, you can add, you can subtract, you can square root. Well, you can log both sides of an equation. You can log that side and that side. Logarithmic property of equality allows us to do that, right? Things remain true. And then after you do that, you can solve for x. And you'll see why that helps. Or whatever other variable you have. Okay? Now, I'm going to do these problems here, but just for that first part, because neither of these require step 1. So I want to kind of show you what I mean by step 1. Here, see how there's all this stuff going on? But this part has the x, so you get this part by itself first, before you even try the next part. Okay, well, let's start simpler. Now, let's look at this problem. 5 to the x equals 42. One of the classic ones that we would not have any way to go with, right? We would just guess and check or estimate, pick up our calculator, start typing in numbers and try to maybe get there, right? We might go, well, I know that 5 squared is 25, and I know that 5 thirds is 125, so maybe x equals, what do you think? 2.3-ish? Sure. And that's still useful. We use it to check our answer when we get the exact answer, because we're about to get the exact answer, not a guess, not a check. Okay? So what we do, 5 to the x equals 42. Well, remember, step 1 was isolate the part with the x. We're lucky here, it's isolated. Step 2 was log both sides. So I'm going to log, you notice I left a little space here. You might want to try to get in the habit of that, because you got to fit a log in here. Okay? So I've logged both sides of the equation. Anybody have any idea why? How that helps us? Yeah?
Because the 5x gets canceled out.
Not canceled out.
X
What
goes to
happens?
the-
It isolates the x
The-
because log is the exponent. No, it will move the x to the front.
Exactly. So the exponent, we just learned, can come out front. Well, when we do that, we end up with x times log of 5 equals log of 42. This just solved our biggest problem, which was that x was stuck in an exponent, and we had no idea how to undo an exponent, right? Well, now x it's out, it's free. It's ready to be getting by itself. So what do I need to do to get it by itself now? What's happening to it?
Solve for the log.
Solve for x, but
Get the log. Divide the log by.
divide both sides by what's being multiplied by x. What's being multiplied by x? Log of 5. So I divide by log of 5 on both sides. These log of 5s cancel right out. And I have x equals, and then my calculator will tell me what log of 42 divided by log of 5 is. And this will give me my answer.
Wait, but because they're the same base, wouldn't you just put it as log 42 over 5?
No, subtraction becomes division. Division doesn't become division. But good thought. So what is it? It should be between 2 and 3. 2.32? Okay. So now 2.32 is what I got. Yep. Now, how do we know if we're right? We have different answers. What would we do to check it? Plug it in. Do 5 to the 2.32 and see what you get.
41.84 is over 100.
14 put what?
Oh wait, are you talking about
41.84? Oh, did we do something wrong?
No, it's
Why didn't we get the exact answer?
Because it's not possible, probably.
No, you found the exact answer.
Oh,
Because
Is this exactly what your calculator said?
No.
No, what did it say?
41.
0.31, then a bunch of other numbers, right?
yeah.
Anytime you round an answer, your check will also need to be rounded, right? So just keep that in mind. Don't be like, I didn't get the right answer. No, you rounded your answer, so your check will need to round as well, right? As long as it's really, really close, you did it right, okay? All right, how about this one? 15 to the x equals 12. Well, again, if we want to estimate, 15 to the 1 is 15. 15 to the 0 is 1. So maybe x is between the two, 0 and 1, right? Because it's less than 15.
Maybe
0.8? Sure, let's check it out. Okay, so 15 to the x equals 12. Go ahead. What's the next step since we're isolated?
divide by log.
No dividing. We're logging both sides first. Then the x comes out front. X times log of 15 equals log of 12. Divide by log 15. And x equals,
0.922.
okay, we weren't that far off. We had the general idea, but now we know exactly, right? Our calculator could tell us exactly if we needed to. Okay. Ready for the only other level to these, right? Because we haven't had to do step 1 yet, but now we will. Now, step 1 said isolate the part that has x in the exponent. So what is the part, the full part that has x in the exponent?
14 to x.
Yep, it's this whole thing right here, this whole exponential expression. So we need to get that by itself, right? So what needs to go away?
6 first.
6 and 5, and 6 first because we add or subtract first. So minus 6, 5 times 14 to the 2x equals 15. Then I would,
Divide by 5.
good. And I get 14 to the 2x equals 3.
Now we expand, like put this into this.
Well, I have something being raised to a variable exponent that I could definitely not think through in my head. So that's your situation, right? You have a variable in the exponent, and you can't guess and check it. You can't think it through, right? You can't common base it. There's nothing that you can make this easier on you. When that's the case, your next step is to log both sides. Yeah. So, like, if you had something, like if you started doing all this math and you got like 2 to the x equals 8, well, you don't need to log both sides, right? You can do that. This we can't do. So we log both sides. And I get 2x times log of 14 equals log of 3. Now I would
Divide by log of 14.
divide by log of 14. Log of 14. And I get 2x equals, anybody? 0.416. Divide by 2. Divide by 2. X equals 0.208. Okay? Make sense?
Yes.
I rounded it to be 0.42, and then I got 0.
If you're in the middle of a problem, just go out a few. Like, what did you get as your final answer?
0.21.
Just keep an eye on what it tells you, like what to round to in the problem, because you usually say round to the nearest tenth or right, something like that. And just until you get to the end, just go like one more than that. And then, because if you round the middle of the problem, it might have implications further in the problem. So homework. So this is the way I'm going to do the homework review today. So homework, I think next year I'm going to like flip the pages, because the back side of this makes you do the rules, and then the front side makes you use the rules, right? So it's almost like the back side is like before the front side. So let's go to the back first, and look at examples of the rules. The two properties, when I say rules, properties are rules, right? They're things that you can do all the time. They're things that you can depend on. They always happen, right? And there were two that we talked about. There was the multiplication property and the division property. And that multiplication or division happens on the inside of a log, right? So when you got multiplication on the inside of a log, you can do something with that. When you got division on the inside of a log, you can do something with that. And when I say on the inside, I mean like right here, like in the answer part of the log. So if we're talking about this one, for instance, this is where you would look and you'd be like, do I see multiplication or division?
Yes.
Yeah, in this case, yes. Some will be more obvious than others, but yes, of course we see. And then over here, it's like, do I see multiplication or division? Yes. Okay, so if you see that as a key, you can use one of the properties. Now the properties say, if you have multiplication on the inside, you can do what on the outside?
Plus.
Add. If you have division on the inside, you can do subtraction, right? So for instance here, and remember it's about expanding the log or condensing. Expanding means pull apart, condensing means bring it into one. This is asking you to expand, so it's pulling apart into multiple logs. So you keep the base for both, so I'd say log base 2, but then I take the numerator, and then I would subtract the same log, but with the denominator. Okay? That's the basic rule. Division becomes subtraction outside. See how this is outside the log? That's inside the log. Now, I'm going to pop around a little bit, because then I'll show you this is one way you should be able to go, right? This way. But you should be able to go backwards too. And that's what this part down here was about. So for instance, if I had this one, number 14, well now it's asking you to condense, bring it together into one log. So I want just the one log, and our base is 10 here, so that means we don't have to write a base. And then I say, okay, subtraction on the outside, so that means what on the inside? Division. So I would go, the first thing, whatever's being subtracted goes on the bottom, so that's u divided by v. Okay? That's your first rule. Now let's go back to the top. The other one would be if we have multiplication, right? Well, multiplication is the same process, but you're adding. So log base 8, 7, plus log base 8, 11. Right? So multiplication comes addition. And then the other way would be like maybe this one, where you have addition on the outside, so you know you can bring it together on the inside with multiplication. And I'd have log 9, 12 times 5. But you notice the answer key, if you look at the answer key, it didn't say 12 times 5. It said 60, right? You would do the math. You would say log 9, 60. In fact, you wouldn't need those parentheses, just 60. Okay? Those are the properties, those are the basic properties. Anything else in the back that we're not sure about before we continue to the front to use the properties?
Do we divide the number 12? Do we divide it or just leave it like that?
Well, 12 is subtraction, right? So subtraction on the outside means division on the inside. So you'd keep your log base, and then you just do 10 divided by 3, and that's it. You can't do 10 divided by 3. If you can do it, do it. If you can't, just leave it. 10 thirds. We would leave it as improper fraction. What's that?
10.
Number 10. Okay, so this is a good one to go over. It's going to lead in today's lesson. So I said multiplication on the inside or division on the inside, but I don't see either. But then I think about what u squared means. Yeah.
It's u multiplied by itself.
Yeah, exponents are multiplication. They're just written a different way, right? This is the same as log 3u times u. Well, now I see multiplication, right? So instead of multiplication on the inside, I'm going to do adding log base 3u plus log base 3u. Now, wait a minute. How many log 3u's do I have? 2.
So you would put 2 log.
Exactly. So this is actually, I would write 2 log 3u, right? It's just like if I had y plus y, I would say 2y. I wouldn't just say y plus y. I would bring it together and just say I have 2 of them, right? And that's going to lead into today's lesson. But before we do that, let's go to the front. Now, on the front, it was a different type of scenario. It was like, hey, I'm giving you some information here. I'm going to tell you a couple logs. This one, so log base 7, 4, well, that is that amount. And also, I'm going to tell you that log base 7, 12 is this amount. And you can use that to find other pieces that you don't know using properties. So for instance, log base 7, 4 twelfths. Well, we don't know that. We weren't given that. We have no way to find that, except we know division on the inside can mean subtraction. So I'm going to break this apart. Log 7, 4 minus log 7, 12, right? And I know what both of those are, so I plug them in and I just do the math, okay? I'm going to not take that all the way, if that's okay, because I think we can both do that minus that, right? Okay. Now, where they get a little trickier is if you're like, okay, they gave me 4 and 12, same two things they gave you, but it says 3, and that's neither of those numbers. So how do I get from 4 and 12 to 3? Right, so you would have to do a little thinking here and say, well, if I rewrite this as 12 divided by 4, that's the same thing as 3, but now I can pull it apart. Log 7, 12 minus log 7, 4, and I can plug in my pieces and I can subtract. Okay. Now, there's a couple others that were even more hidden than that, like number 4. So number 4 is very similar to one of the problems we did in the back, in that it doesn't look like it's multiplication, but maybe it actually is. Thinking about what you have, right? This is what was given. Is there a rule that says you have to use both of them? No, they're just given information that you are to do what you will with, right? So maybe I just have to use one of them. And if I just use one of them, how could I get to 16? 4 squared, or 4 times 4. So that's log base 7, 4 times 4, which multiplication on the inside becomes addition on the outside. Log base 7, 4 plus log base 7, 4, which, again, we can even go further now. We can say that's 2 times log base 7, 4, or 2 times that. And that's your answer. Either way, if you added it to itself or multiplied it by 2, you get the same answer. Okay? Make sense? We're ready for the warm-up.
Can you do number 6?
Number 6, I'll help you set them up. Well, 5 first then. Okay, 64, very similar to the last one. You don't have to use everything. Do you see it now? 4 to the third, so that's 4 times 4 times 4. Now this one is a little bit different. Now, remember yesterday or last class in our example, we said, hey, they give you this, right? So they give you this one, they give you this one, but we know some already that aren't necessarily given, but we're expected to know, right? Like, for instance, we know log base anything 1 equals 0, right? Anything to the 0 is 1, right? So if 1 is our answer in any log, it doesn't even matter what our base is, that log is equal to 0, okay? We also know log of any base, and then the answer is also the base. It has to be 1 because anything to the 1 is itself, right? So how does that help us here? Well, we know that log 7, 1 equals 0, and log 7, 7 equals 1. Now, we don't need necessarily both of those. I'm just saying you should always keep both of these in mind. Both of these in mind, right? Anything to the 1 is itself. Anything to the 0 is 1, right? Now, let's go back to this problem. So, We have 1 divided by 4. How can we pull that apart? Yep, log 7, 1 minus log 7, 4. Okay, this one was given, right? Right here, we can plug in for that. What else do we see now? Is 0. All right, so this, I'll take this one all the way. So that gives us 0 minus 0.712, which is equal to negative 0.712. Okay? Does that make sense? Okay, now are we ready for the warm-up? All right, so back to the lesson. Okay.